All right. Welcome to the session on exploring Nashhorn. My name is Venkat, Subramaniam. We're going to talk about what this particular feature is in Java 8 and what we can do with it. Best time to ask a question or make a comment is when you have it, so please don't wait till the end. And if you do have a question or a comment, please draw attention, start speaking, say question or something, and that way I know that you do have a question. Otherwise, it's going to be really hard for me to know who is asking a question. So please do ask questions. Don't wait until the end. Anytime along the way is a great time for questions or comments or just about anything you have to say. So let's get started. What is this and why do we want to do something along these lines? So Nashhorn is really a server-side engine for executing JavaScript. Now, if you really think about this, if you heard the story of this guy back in 1995, was a programmer. He fell off the cliff, landed in a cave, and they took about nearly close to 20 years to rescue him. You heard that story, right? So as soon as they rescued him, the first question he had was, I was a programmer when I fell off this cliff. I'm curious to know what language people are talking about. And they told him, why, JavaScript, of course. And he said, nothing has changed then, right? So it feels that way. In a way, it feels like JavaScript is that villain in the movie, and they try to kill him, and he keeps coming back every single time. Much more stronger and uglier each time. It feels that way, isn't it? Well, JavaScript, if somebody told you that JavaScript will be the language that is the most exciting and you could run this on the server side, you would have said, you gotta be kidding, that's not true at all. Well, it turns out that's really not the case. We have JavaScript really very powerful. There are so many implementations for JavaScript on the server side. Well, JVM, of course, has one benefit. It provides an ecosystem for over 200 different languages to run on it, so why not JavaScript? Now, one question you may have in your mind is, yeah, but didn't we have Rhino in the beginning? Why care about something else? Well, first of all, just a little trivia, you probably are aware of this. Well, one of the first JavaScript books from O'Reilly had a rhinoceros on its page, front cover. You know how O'Reilly publishes a book with animals on it. Well, that kind of triggered off a sensation, and so a lot of things associated with JavaScript have to have something to do with rhinos. And so Rhino, of course, the engine for Java, the Java engine, JVM engine for JavaScript was called Rhino. Now they have to recreate it. What did they name it? They named it Nashhorn, which I'm told is a German word for rhino, so a little trick on the word there. So that is basically what this is. Now, what is the main difference? Why would we want to do this? Well, a couple of different reasons. You probably have JavaScript you're writing, and you are like, hey, wait a minute, wouldn't it be nice to really reach out and use these Java functions I already have? That would be nice if we can do it. Well, you don't have to think about how wonderful it'll be, you can actually do it. Or you're writing Java code and somebody says, well, we have a JavaScript library to do that already. Well, it would be nice to really be able to use that. In other words, we got to quit being in denial. We are in a polyglot programming world right now, and several people are using multiple different languages on the JVM already, so this is really a nice thing to be able to integrate and use it. So let's take a look at how we could actually do this, and why, of course, Nashhorn, because one of the things that really happened with this is shipped with Java 8, and one of the key strengths is not only the interoperability and all those good stuff, it is a JavaScript server-side execution engine. I talked about this, but one of the key things is the Java interoperability. But of course, when it comes to Java interoperability, we always worry about how does it work, what's the performance, and so on. Well, one of the key things that they did here is to provide invoke dynamic. Now, really quickly, about 10 seconds on invoke dynamic, it is a way to optimize calls into different functions whose behavior has to be postponed to runtime rather than being known at compile time. Now, naively, we may assume, oh, of course, that's a feature for implementing dynamically typed languages on the JVM in a meaningful way, but it turns out one of the languages that mostly benefits from invoke dynamic is Java itself. Java 8 wouldn't be where it is if not for the invoke dynamic. But I'll sing all the praises of invoke dynamic in a separate talk tomorrow if that's a topic that's of interest to you. you, but this uses invoke dynamic quite a bit to make this happen, and that is again baked into this particular engine. Well, let's talk about how we would use this. There are two ways we can use it. One is a standalone engine, and so if you really want to only run JavaScript, just like how you would run Node.js, for example, you could use this as a standalone engine if you're interested. Or alternately, what you could do is you could also use this as within a Java code itself. We'll talk about both of those here along the way. But I want to start with a few JavaScript fundamentals, not too much, just a little bit, for us to get a feel for it real quick. So a couple of things I think we should keep in mind about JavaScript. JavaScript is a very powerful language, but it makes you work hard to get that power. JavaScript doesn't force you to write bad code, but we kind of bring it on ourselves to do it quite often. So there are a couple of things we can do to prevent that. Well, the very first thing I want to show you here is how we can define functions. So I'm going to create a function. It's a rule that you can never have a talk without foo in it. So I cleared that checklist, as you can see here. So here's a function called foo I've written. And within this function, of course, I'm going to go ahead and just print a little bit here. So I'm going to say print, and I'll say foo called right here. And I want to call this function foo, so we could just call the function foo just like that. So I've defined a function called foo. This is a format I like to use for defining functions, rather than the old format people often use where they start with a function to define it. But let's say I want to define a class. So I'm going to say car equals function, and I'm going to go ahead and define the function. And so we defined a car class right now. So you may look at this and say, really, is this a car class? Absolutely, it's a car class. You look at this and say, wait a second, are you trying to fool us? Because they look almost the same. Honestly, they don't, because pay attention. Did you notice the uppercase letter in here? So that is a convention in JavaScript, that you define classes with the uppercase and functions with lowercase. But in reality, you don't define classes in JavaScript. We kind of colloquially say we're writing a class, but we really don't. So what did we really do? Well, what we really do is we'll say constructor called, and this really is a constructor we really are written here. So if I say, for example, car1 equals new car, and now, of course, I just created a car object, you can see the constructor was called. So this tells us that we are calling a constructor in this case. Of course, we could pass parameters to this. So what we would do here is we would say this dot year equals the year given to us. And we can, of course, ask this car print, and we could say car1 dot year and get the year value out of it. Likewise, what we could do, oh, wait a minute, this dot year, of course, I got to pass. But notice JavaScript did not complain to you, because it treats you like a guest in its house. It never tells you you're wrong. It quietly laughs at you behind you, right? So that's what it just did here, right? So you can see in this case, it didn't complain really, but it failed when I ran the code. So right there, it did that. Of course, we could say, for example, car.prototype, for example, prototype a dot drive equals, I'll create a function, and then we could say, for example, here something along the lines of print, and why not simply say driving, and I could now say, for example, come down here and say car1 dot drive, and we could even specify the miles you want to drive or kilometers, and you can see it called. Now, of course, notice I didn't pass the parameter here, but I didn't say anything to accept it. That's another feature in JavaScript. In JavaScript, it's a feature. What else can it be, right? In JavaScript, you don't have to say any parameters if you don't want to. So, for example, if I really want to get to that parameter, I could say distance over here, and I can access the distance within here, for example, driving, and I could say dist over here. That's one idea if I wanted to do it, but nevertheless, I could also omit it completely, and I can also say print and arguments over here, and I can get the value out of the arguments collection, and in this particular case, arguments is going to be the value or the collection that's going to hold the values out of it, and sometimes, for some reason, I'm getting an error here. Let's see what that error really says here. So that's going to be the way to get the arguments. I need to dig in and see what it's doing, but nevertheless, that's basically the point is you don't have to pass the values. You can really get the values through arguments in JavaScript. So we looked at a couple of different features here of JavaScript that are kind of little different or tricky. But I don't know if you noticed so far, I used the word print along the way, and there's a reason for it, because I was running the JavaScript in Nashorn actually all along. So that is what we were seeing is an execution of Nashorn. So how do you really run this? We ran this as a standalone right now, and the way to run standalone code is as follows. So I'm going to say print over here, for example, hello, and we'll come back and take a look at this in a second. I'm going to go to the terminal for a few minutes. Let's go ahead and play with it. I'll increase the font size in just a second here. So in this particular case, I'm going to go ahead and create a file, but we'll come back to that in just a minute. So what I'm going to do here is I'm going to go ahead and say run the code right here. This gives us what is called a REPL. REPL is one of my favorites. A REPL gives us the so-called read, evaluate, print loop. This is a great way for us to experiment and play with a little bit of code. So when you're writing JavaScript code, if you're not sure how something works, the really bad way is to write the code and run the entire code. Instead, open a command prompt, bring up the REPL, and try out a few little examples. For example, if I say 2 plus 3, well, it tells us what that is. We could also say print hi, and you can see that it prints that value also. So this is an interactive shell we can use. But of course, I want to run real files out of it. So I'm going to say sample.js, and within this file, I'm going to say hello over here. And I'm going to save that file into a file called sample.js, as you can see here. And now I'm going to say jjs and simply run sample.js, and you can see that ran that file as well. So that is an example of how we can run this from the command prompt by simply running the interactive shell, or by running the file name and bringing up the code to run. Well, the Nashorn runs in 2 modes. By default, it runs what's called a strict mode, where it assumes you're writing a regular JavaScript, but also there are a few extensions that Nashorn provides to you, and if you want to make use of those, you would use a scripting mode for those. Let's take a look at some examples of this. One is my favorite, extensions. For example, if I say var name equals, let's say Joe, and I wanted to go ahead and print over here hello plus name over here to print it. Anyone who has done code like this in Java and JavaScript? Yeah, all of us, right? And I can fully understand why you don't want to raise your hands, because the thought of it really stuns you, right? Absolutely. We've all done that. But that is so sad. We have to write code like this. It's noisy. It is not very fluent. Wouldn't it be nice if we can do something along these lines? So I'm going to say print, and I'm going to say hello, a dollar name. And if you run this, you can see how wonderfully it printed hello and dollar name. That is because it's called a literal, and a single quote stands for a literal. If you really want an expression, you want to put that into a double quoted string, and you can see now it actually runs it as hello Joe, because it knows that it's an expression, it evaluates it, expands it. For you to be able to use this option, you would have to run the Nashorn with a minus scripting option, and then sample.js, the file name, and only then this option will work. Now, of course, the obvious question is, programmers never take solutions for an answer. They say, what if I do this, right? Sure, if you do that, it would just print hello dollar curly name, and you just ignore you saying, hey, I don't understand what the double quote is, and simply ignores you at that point. So that is one thing you could do, is you can use expressions like that very nicely. Another of the feature is really nice is really writing multiple lines of text. So for example, you could say message equals, and you could say something along the lines of end of message, and you could say hello dollar name, and then you could say something along the lines of hope your day is going great, nice meeting you, and then cheers, and then you could say end of message. So in this example, what I've done is I've created a little example of a message which is flowing across multiple lines, and I'm going to say name equals Jane over here, and we're going to go ahead and run this code in a second. So I can simply say print over here, and now I can simply write message, And you can see that in this particular case, it says, hello, Jane. So you have a multi-line string. So imagine where you can go with this. Not only can you write a multi-line string like this, you can quickly put that into a loop if you wanted to. And then the name can come from a collection, and then you can take the message and you can email it out from JavaScript. Not only it makes it easy to create a multi-line string, it also makes it very easy to spam as well. Notice how powerful that feature is. So you can write this very nicely as a multi-line string, and it kind of monitors until obviously you want to pick something that doesn't quite is in part of the text itself you're writing. That's called the here doc. But there's another feature we could actually use, which is called a shell invocation. So for example, if you are writing a piece of code where you want to call into an external program. So for instance, I like to talk to things on my system often. I write code to interact with other things on my machine. So I may say svn help, for example. And notice very promptly it printed svn help. That's not what I really want. I want real help in this case. So what I can do is I can replace this with a backtick, as you can see here. And now you can see the output is not help anymore. It is actually the output of the help from Subversion itself. So we can see how easily we can create this. But not only can we do this, we can also easily create a very powerful scripts on our machine as well. So for example, let me again increase the prompt here, or the font here for us in a second. So let's say for a minute I'm interested in creating a file. So I'm going to create a run.sh file, and within this I'm going to say print backtick svn git, let's say git help, and I'm going to say close the backtick. So that's a little JavaScript, as you can see. And I put it into the file called run.sh. I can do is change mod on run.sh. So that is an executable file right now on my machine. Unfortunately, if I say run.sh, it spits on me, calls me names, and tells me what are you trying to do, because obviously it's not a shell that it understood. So I'm going to go back to the file, and I can use a shebang, and I can say, for example, user bin env and run jjs, and of course in this case I want to run the scripting option on it. So I'm going to turn on the shebang on it, and now I can go back and run this, and you can see that's the output from this file running when it ran the git help, as you can see. So you could write JavaScript. Now this is very powerful because on my machine I write a lot of scripts for doing stuff, but I don't want to, and honestly I don't care what language I wrote it in, and I want to just run those scripts on an everyday basis. And the only time I care what language I wrote it in, with all respect to languages, is when I have to edit it, make some changes. So when I have these scripts on my machine, I often use shebangs for it, and as a result I can just go into these directories and run the scripts, and I don't have to know and worry about languages. That can make it very flexible, as you can see just here, and you can do that with this as well, and you can run it from here. So if you have JavaScript libraries of some sort, you can easily run them using shebangs and write scripts for yourself and work with it fairly easily, as you can see in this example. So we saw examples of running the standalone so far, but I'm going to go ahead and run this in an embedded mode from within JavaScript right now. So let's see how we're going to do this. So which means we got to bring in JavaScript for us to be able to, Java to be able to use this. So what I'm going to do is, here's my Java code, as you can see, the friendly Java code that you can see up here. And within this, of course, I'm going to start by saying import, and I'm going to bring in everything from JavaX, a script package. So the very first thing I'm going to do is script engine, and I'll call this as engine as Nashhorn, and then equals to script engine manager. So the minute I write the word script engine manager, do you feel that sigh of relief? It's like, I'm in the Java world. Yes, I have factories on my hand right now, right? So we create this script engine manager that we wanted to create, and then we're going to say get script engine. So we're going to say engine by name. In this case, we're going to say engine by name over here, and I'm going to specify Nashhorn as the engine I'm interested in. So once we get the engine on our hand, what is the next thing we're going to do? The next thing is, of course, we want to evaluate something and run it. So for that purpose, what I'm going to do is I'm going to say over here Nashhorn, and I'm going to ask it to evaluate. And what do I evaluate? New file reader, and I'm going to specify a file for it to read, and this is going to be the file called sample.js I'm going to read from. So that is all I have so far, and of course we need to import the java.io because I brought in the file reader, so we'll bring those things in. Well, that requires the sample.js file, so let's bring up the sample.js file. It doesn't have anything, and I'm going to simply say print, I'll say hello from JS, so I'm going to just print that here in the JavaScript. Now, of course, I could run this directly in Nashhorn, but I'm going to run this as an embedded into the Java itself. We'll take a look at some variations of this in just a minute or so, but let's go ahead and run that. Oh, of course, Java kindly tells me I need to handle file not found exception. This is a battle I've been having with Java for a while because I know the file exists, Java knows the file exists, but we got this feud going on for a few years now. So, but as Java programmers, we know exactly how to handle it. So we'll say throws exception and be done with it, right? That puts an end to all those problems. So I'm going to run it, and you can see how hello from JS popped up. So we just ran this as an embedded script here. So of course, you're like, okay, that's great. You ran this code separately, but we could have done this by asking for Java to invoke a separate process. We already know that how to do this for a long time. And the process could have been JJS, Nashhorn, but we want something a little bit more. We want to get access to that result that it's returning from there. So notice what I'm going to do. I'm going to remove the print statement from here, and I'm going to say hello from JS really, and this is going to be just a string that I have defined within the JavaScript. Now if I go back and run this, you can see the quietness because of course the JavaScript didn't print into the standard output. So what I'm going to do here is I'm going to go ahead and say right here, I'm going to say output that value that it returns as an output, whatever that may be, and I'm asking it to return it, and you can see that that's an output from running the JavaScript. So whatever is the last expression in the end of the writing the JavaScript, that expression was returned, and then we grabbed it here as an object. If you wonder what kind of animal we have on our hand at this point, you can simply store that and examine it. So for example, you could say object result equals, and then we would go back here and ask it for output the result itself, but more so, instead of outputting the result, we can say output dot get class to see what in the world we are handling, and so we know that it's a Java lang string. So that is one big difference now we have to keep in mind. When you are using Nashhorn, you are really dealing with Java types, even when you're writing JavaScript code, and in places where you are more familiar with a certain JavaScript type, they map over to Java types, and then you are dealing with it. So you can actually use Java types in both sides now, and then you can pass them around as well. So what we saw so far is embedding this into a file and executing it, but you can also do this as a string if you are interested. So for example, what we could do here is rather than writing this as a file, I'm going to remove that file for just a minute, and I'm going to say blah here, as you can see. That is just a string I'm going to evaluate. So I have to evaluate a string over here. Of course, that has to be in a string itself. I forgot that. It's a JavaScript that you're going to provide here. So that is a string I'm providing in this case, and you can see that it brought back the blah, and that highlighted code is the JavaScript code, as you can see. Or you can put it into a variable if you choose to. For example, you could say stir, and then you could say string stir equals, and then you could put that string right here. So whatever that string is, whatever, and you can then pass that around, and you can have that evaluated as well. So that is a string executing in this case. I'm going to fall back to the file because putting strings into code into string and evaluating is the best way to become insane. So I would not recommend it unless you can recommend this to colleagues you hate, but you don't do this to yourself, right? So in this case, I'm just running this as a separate file, as you can see. So that works just fine, evaluating it. But what about getting the result? We already saw how to get the result. And we were able to get this variable and say, hey, what is this result value? Print it, what have you. But let's go a step further. I want to be able to call different methods from the Java side. So let's get back to this JavaScript code for a second. I'm going to write a function here, function equals, let's go ahead and say foo. with a parameter. We'll call it as number here, whatever that parameter is going to be. And then we will say here simply print, and let's go ahead and say foo called. Actually, let's call this as greet. How about that? So we'll say hello, and we will go ahead and print the name over here of the person that we're going to pass as a parameter. Right there is the name. So in this case, we got a greet function we are interested in calling. And how do I go about calling this greet function? Notice the greet function takes one parameter and it prints a result, but we will also return thanks for calling, and then we will say plus name, and we're going to return that. So let's get back to the Java code. And here we have the object. We're going to evaluate it. So I'm going to go ahead and call the evaluate method, as you can see. But when I run this code, it has the, what does it say here? Oh, it's complaining because I made a syntax error. That's because I got to say greet, and I have to say function here, of course. There we go. So let's go ahead and run this. It's quiet, as you can see. The reason is it evaluated the JavaScript. There's nothing printed out. So it evaluated and said, yep, I'm done. But of course, we have a function, beautiful function sitting in there. We want access to it. So I'm going to say invocable over here, invocable. And this invocable is going to come from the engine itself. So I'm going to say engine over here. And once this is going to be, of course, Nashhorn engine. And then once we get the object that we are interested in referring, I'm going to say invocable dot, and we'll say invoke function. And the function we are interested in invoking is the greet function. And we will pass over here, let's say, Joe here as a parameter, and we can receive the result over here into object result equals. So we ran this little code, we received a response from it, and we have saved it into a variable. And you can see it printed hello Joe, but not the thanks message. Of course, that's because that message is sitting with us here in the result, and we can see, oh, wait a minute, it said hello Joe, but what happened to the result itself that we were supposed to get from this? Let's make sure that's happening here, and that's because I forgot to put the word return. Now, this is another conflict I'm having with languages. I'm working more and more with languages where return is not required, and then there are some languages like Java and JavaScript that still insist on putting the return keyword within a function. That's why that didn't quite work, and there you go. It says, hello, Joe, and then thanks for calling, Joe. So you can see that the result is being obtained back from the string, and it's being printed. So this shows us how we can use the invocable and an invoke function on it. We also saw how to pass parameters. But we don't stop at that, right? We want more from this particular engine. Well, we could deal with interfaces as well if you're interested. So for example, let's go back and make this a little bit more. So I'm going to say var by equals function another name, and we're going to say print here good seeing you plus name over here, right? So I'm going to just only print good seeing you and seeing you, of course, and I'm going to just print that information. I'm not going to return anything as a result from this particular function. So how would I go about calling these two functions now? Well, sure, I could have done the following, right? We could have said invoke function, and I could have said by. In fact, let's go ahead and do that. We could actually go back here and say invoke function by, and then we could say Joe, and over here, of course, I don't want to reuse the result. I don't have any results to get back. So in this particular case, we can see that it says good seeing you, Joe. But the problem with this is we are calling this onesies and twosies of functions, and at a certain point in time, we want to be just able to call those functions with respect they deserve, rather than putting them in double-quoted strings and making mistakes along the way. Would be nice to really be able to do that, isn't it? Well, we can actually do that. We can also get some compiler support along the way as well. So I'm going to go ahead and create an interface here, a public interface called greeter, if you will. So I have a greeter interface, and I'm going to have two functions within this. I'm going to say string greet string name over here as the first one, and I'm going to also create a by function which takes a name as well. Well, clearly one of the best things we're going to have right now, the minute we put an interface, is we readily can use the IDEs to verify the method names are correct. The compilers can verify the method names are correct. The IDE will prompt us with ability to select these methods. So coding becomes a lot more natural. So those are some of the advantages of doing this. So what am I going to do? I want to call those two methods, certainly the greet and the buy method, but we created an interface called the greeter interface. So what we're going to do here is we're going to say greeter equals, and in this case I'm going to say invocable dot get interface, and you got to tell him what interface to morph it over to. So in this case I'm going to say greeter.class and ask him to convert it to that particular interface. So once we do that, the next step here of course is to output the result of greeter.greet, and I'm going to say Sarah here. Let me put the double quote as Java would understand, and we are calling that method on Sarah, and you can see hello Sarah, thanks for calling Sarah. And then we can also say, for example, greeter over here dot buy, and send off Sarah here along the way, and we can see that we can call the buy method on it. But in this case, you could actually pass this particular greeter around to other parts of your code, and the code doesn't have to care whether you wrote that interface implementation in Java or JavaScript or other languages. So you can pass it to other functions that can take greeter, and all of a sudden parts of your code that was written separately can use JavaScript without really knowing or caring that they are using JavaScript. So that gives you an ability to pass interfaces around as well, with of course a certain amount of limitations you have to run into. So this is coercing the interface, and we were able to get these different methods and use it. But wait a second, please. A little louder, please. How do you invoke methods starting with $1, for example? I would expect you to open your wallet and take that money out and give it to me. No. So what if the method names are kind of methods in JavaScript? So one of the things is, any language that wants to interoperate with other language has to give you some kind of a backdoor. So what you would have to do in that case is, you can go through the invoke function, and remember it takes a string, and you can pass any string, and that's just passed on to the engine, and the engine will have to evaluate at that point. You may not be able to have a fully qualified name on your side because JavaScript doesn't like that syntax, but there's always an escape clause. That's where the invoke function can give you the backdoor to be able to go that. I mean, kind of fully understand, hey, what if I have jQuery methods I have to call? So there are a couple of things you can do. One of the things you can do is you can just expose those methods and give it to Java side, which burdens you a little bit. Or alternately, what you could do is you could write wrapper functions in a hygienic or more fluent method names, and be sensitive that when you're dealing with Nashorn, your intention partly is to be able to interoperate, so your boundaries have to be a little nicer. I always say that this is like you being here, you're nicely dressed, but dressed up, but I'm sure that's not the way you sleep in the night. So that's kind of the model I use, right? They turn off the light the minute I say sleep at the night. Okay, so the point really is, within the system, be whatever you want to be, right? We don't care you're in underwear or not, but if you're going to open that door, we expect a certain amount of civility. So that's exactly how I treat this as well. If you're going to interoperate, be a little bit more civil in your interface so you don't have to deal with those problems. But internally, hey, who cares? Do whatever you like to do. That's kind of what the logic I would use. So that is basically, but wait a minute, we want to be able to really call something where we want to pass a parameter. These were all right, but what if I have something like print line hello plus name like this? So if this is all I have, like a raw script, there is no functions at all in it, and even if I have functions, I really have a file scope variable I'm using, and I want to be able to call that method. What do I do? How would I be able to deal with it is the question at this point. So let's go ahead and try that. So what I'm going to do here is simply call the evaluate, and to make sure this evaluate actually is working, and I'm going to simply replace this with name goes here for a second. We'll come back and fix it in a minute. So in this case, of course, I want to call that method. Of course, I want to call it with a print, not a print line. So that's why I want to make sure that part actually works. And you can see that it says print hello name goes here. but I really want to go back here, and in this case, I'm going to send name and not that particular string. So you can see in this case, I got hello name, but where in the world is name? Name is not being defined anywhere. So if I run this code, you can see it blows up on my face, and it tells me that name is not defined in the evaluated string. That's an exception. It says it's a script exception. So if I had been a nice guy and not done this, I would have actually put two exceptions up there. One is the file not found exception, and the other is the script exception. So I can separately handle the script exception, and I can do whatever I want to do with those exceptions separately. I would wrap it with a try catch block, and I would handle a script exception to deal with situations like this. But of course, in this case, I don't care to handle the exception. I want to fix it. So what am I going to do? So what I'm going to do here is I'm going to go to the engine, which is Nashhorn, and I'm going to say get bindings over here. And once I get the bindings, I'm going to say bindings equals. So I'm going to say bindings equals that. And I'm going to get the bindings from it. That's all I did so far. Excuse me. I'm getting the bindings over here. Well, it's complaining at this point. It doesn't know what I'm talking about because the bindings requires a scope variable. Now, what in the world is a scope? Now, there are two scopes here on our hand. Notice that in this particular example, on line number 11, we used a scripting manager, and then we obtained a script engine at this point. So there is a scope of the scripting manager, and then there's a scope of the engine. So those two scopes are called as a global scope versus an engine scope. An engine scope is a scope within the engine. A global scope is a scope at the upper level, the manager level itself. And of course, if you define something at the manager level, the global scope, any engines that you use in your application will see it. So if you have multiple engines in your application that you're using, and you want to take a variable here and have it available in the other engine, you can do that using the global scope. But on the other hand, if you're really caring about your current scope you're dealing with, you can say that this is the engine scope rather than the global scope itself. So I'm going to say over here, script context dot engine scope over here, which is the scope I really want to use, and I'm going to say that is my scope in this particular case. So now that I've defined the scope, the compiler is happy with me. So now I'm going to say bindings dot. Now this is the easy part. The bindings really is a hash map. So you specify what your parameter or variable names are and what the values are for this, and that is all you have to specify. So life becomes pretty easy at this point to work with. So all I'm going to do is go ahead and put into it a variable called name, and in this case I'm going to say mark over here, and we are passing that variable, and you can see it says hello Mark right now. So all we did was we bound this name called name into the bindings, where the bindings came from the get bindings, and the name itself we bound to Mark in this case. And so if we go here, we can see that we bound that to the name and said hello Mark, and that prints the details of this particular variable. So we can use the binding, and like I said, the scope can be either an engine scope or a global scope, and I recommend dealing with the engine scope as much as you can. You don't want to overreach into the global scope as much as you can. Keep it to engine scope. That's a lot better, unless you have a very good reason to go to the global scope and mess with it. So that is an example of how we can use this from within Java. We have embedded JavaScript within Java, and like I also said, I am definitely not a fan of putting JavaScript into a code, and I'm sorry, putting JavaScript into a string and then using the string to evaluate. As we all know, JavaScript is already a terror to deal with, and you will really make it angry if you put it into a script. So it's better to put it into a separate file, and then you can use that into your code. That's a lot better, a more civilized approach. So you're treating JavaScript humanely. That's a good thing, right? So that's what I would recommend. So we put it into a file, and then we call it in Java, and we are able to interact with it. We are able to pass parameters to it. We were able to get results back from it. We were able to even tie an interface to it and work with it. So we looked at a few different combinations. But let's look at on the other side one more time. We first started out by looking at how to use JavaScript within Nashhorn. Now, then we looked at how to take JavaScript and use it from within Java, but let's reverse it now. We're going to go back and use JavaScript as it is, but we're going to call into Java at this point. Like, why would we want to do it? Because maybe we're a really good fan of writing JavaScript, and we realize we can actually write this in a more efficient way, or at least a more expressive way in JavaScript. But we really want to use that library that's already written in Java. Why we want to interact with existing systems in our enterprise. This gives a nice way for us to call into the Java code from within JavaScript. So for doing that, I'm going to get back to the JavaScript right here, and I'm going to say again print line hello over here. So this is purely JavaScript running within Nashhorn. That's what we are seeing at this point. So what I would like to do is I want to embed Java into this. In other words, I want to say, hey, I want to call Java code from within here. Well, I do have to say that JavaScript treats Java a little bit more kindly than Java did to JavaScript a few minutes ago, right? So it's going to allow you to really, not really embed. It is a lot more smoother integration. You're actually going to be able to directly use it. And so it feels like you're writing JavaScript, but you're really calling into the objects much like they are JavaScript objects, but except they are really Java objects. So how do we go about doing that? Let's start by looking at calling a static method. So here I am, and I want to call a static method. What method do I want to call? I'm going to say java.lang.string.value of, let's say 2, and I'm going to run that method right there. So we call the value of method within the string class. So we said Java lang string, and we specified it, and that worked really easily, as you can see. So this is a static method called value of that I called. So if this was your own class, what would you do? You would simply say my class dot whatever method you have, which is a static method, of course, and then you would pass whatever parameters that you want to pass to it. The only thing you got to make sure is that your class, what did I call it in this case? I called it as my class. You got to make sure that my class has been compiled, and whatever the jar file is that's available in the class path for Nashhorn to find. So when you run Nashhorn, you would say JJS minus scripting, if you want to use a scripting option, that is, but you'll also say minus CP and specify the class path where your Java code resides, and then this guy will be able to pick it up and run with it. So that's what you would have to do to specify where it's coming from. But I'm a little lazy here at this point, so I simply use the existing function. So java.lang.string.value of, and then I simply specified a value to go ahead and run it, as you can see. So we called a static method, but what if I want to call an instance method? What would I do to make that work? So in order to do that, let's go ahead and say file equals new java.io.file, and I'm going to read, oh, what can I read? Let's read the same file itself, sample dot, let's say this directory. Where is this directory located? So I'm going to provide the directory right here, and then I'm going to output print file.get absolute path over here, and ask for the absolute path where this is located, and it tells you where my files are located in here. So you can see that in this particular case, we are able to call an instance method. The instance method is called the getAbsolutePath method, and we were able to call that method on this object. As far as we are concerned, this smells like JavaScript code for all that we do, except this class actually is from Java rather than written in JavaScript or other libraries. So that is an example of how we can use it. If you're curious to know what you're dealing with, you can simply say file and print the file itself, and you can see that, well, it printed the value, in this case the toString value. Let's do a get class instead and see what it tells us, and you can see that it's an object of java.io.file. You're pretty much dealing with the raw Java class at this point very effectively. And how so? Well, it's really simple. The JavaScript is actually compiled down to bytecode. So once it compiles down to bytecode, this is like writing code in Groovy or Scala or Clojure or what have you, or Java itself, because the source code is compiled down to the Java bytecode. And so there's no surprise that from any of these code, you can actually call into Java code or Java classes. So while at the first sight it looks like, whoa, that's really awesome, it really is not, because all we are doing is we're compiling this down to the Java bytecode, and we know that we can do this from multiple different languages. In this case, we are just doing this from Java itself. I'm sorry, JavaScript itself. That's what is this. So we looked at how we can get the instances out in here and talk to the static methods and instant methods. But there's one problem here, as you can see, that we are dealing with. And that is, every time you have to access a particular object, you got to give a full name for it. And if you have to give a full name for it, the code becomes pretty noisy. And it becomes really hard to type. Even if we invent shortcuts, it also becomes noisy to read the code as well. So we enjoy the import statements very well in Java. So it would be nice to have imports here as well. Well, we can certainly do that. So I'm going to grab that file.io, and I'm going to simply say imports over here equals new Java importer. And I'm going to simply specify whatever I'm interested in specifying here. So now we can simply say something along these lines. Let's try this, imports dot, and see what it tells us. So that worked, as you can see, but that's again a little ugly. Would be nice not to have that. So there's a feature in JavaScript called width. So what is width really? Well, width is a feature. Let's see if we can actually use width here. Really kind of fun to do that. So let's not worry about the imports for a second. So let's come back and say java.io.file. Let's just do that for a second. And I'm going to say over here, print file.get absolute path. So we can call that method right here. And let's imagine for a minute I'm going to call that method a few times. It could be other methods on file, doesn't really matter. Now what I would like to do is I would come back here and say with file, and let's see if that actually works. So with file, and I'm going to take this code right here and move it into this context right here. And now, oh, wait a minute, he's not happy with that. So what's happening? Because it probably is confused about the print line. Let's ignore that for a minute and just get to the point where it doesn't complain about these things. So let's go ahead and try that. And print line, I'm going to say outside over here. So outside. Let's go ahead and try that a little bit. And again, line number 3 is complaining. Let's go back and see what I did in line number 3 for him to complain. So this is the with command that I'm going to use. Let's go ahead and make sure that he's happy with the code so far and not complain. Yeah, that was all right. So he's having trouble with something here. Let's lower the font and see if we can see the error actually. It says type error. That's interesting for the width. So let's see a little bit more. Okay, a little louder, please. Aha. So you're saying in the width I should remove what? Inside this. Yes, I'm coming to that. I'm coming to that. So what I really want to do is, yes, I want to remove that. Absolutely, that's where I want to go to. But I want to be able to call methods like this. That's what I'm trying to do. So there's another error before even I get to that point. So essentially, that's what I want to do. But that doesn't want to work with. A little bit ambitious that I wanted to show you how we could actually do this coolly in JavaScript. But let's get it going a little bit further. So what I want to do here is I wanted to use that imports. We define the imports over here. So let's say we have these calls to this function here. So we have this particular code which is running. So we could say with imports, for example, and with the imports, what we can really do is we can forego that particular prefix that we would have to use on this particular object. So notice in this particular case, what I did was I said, I'm not going to use the imports, and you resolve the context for me and figure out where the file is coming from. And that's what we just did here. So that seems to pick it up very nicely. So the width is a concept available in JavaScript where the idea really is if you put a width and if you don't put an object context, those methods will automatically go to whatever that context object you are using up there, and it will be able to use it. That's what I was trying to show you with the other thing, but that should be something that I need to debug and see what it's doing. So we can see that. Well, that's great so far, except there's one problem. I use the Java importer, that's nice, but let's try the trick one more time and see if that works. So I'm going to go back here and say, comma, java.lang. And what does java.lang give me? Well, it gives me a lot of different classes. So for example, I could go back here and I could say var runnable equals new runnable. So we could create an object of runnable, for example, right? So what if I really want to refer to runnable? So let's go ahead and say print runnable. And I want to just print out the runnable itself. And it quietly printed runnable. Where did runnable come from? Of course, it came from Java lang. So if I go up here and remove Java lang over here, you can see it really got upset and scolded me, and that's because it doesn't know what runnable is anymore. So we put Java lang runnable. That seems to work. But let's get a little step further and say, hey, I want to say string.value of 5. Remember that we did a little bit ago. So I want to call the string in this case. And what did it say? It said something completely absurd, right? And you will only appreciate this if you're in tune with JavaScript, right? So you look at this and say, of course, it's my fault. You never say JavaScript's fault. So what really happened here? Well, it turned out there is a bit of a conflict. Java itself has a string, and JavaScript has string. And which string are you really referring to? So in this case, of course, I really wanted the Java string. And JavaScript said, but you didn't tell me that. So Java lang string is working just fine. So what can we do? Well, this is where, when things really don't work, what do? Well, you used a structure, and that didn't work. So what do? You use more structure. So this is like violence. If it doesn't work, do more of it, right? So in this particular case, you're like, okay, that didn't work. I'm going to try another thing. So what do? You say JS string, or if you want to call it with uppercase, you could say JS string. I don't care what you call it, but keep consistent. In this case, because it's a class, I would like to start with the uppercase. That's a lot better. So I'm going to say var JS string equals java.lang.string. So we did a little aliasing right now. So once you alias, JavaScript says, okay, cool. Anywhere you use the JS string, I will assume you're really talking about the java.lang.string. So you basically give a reference to the object. Well, in this case, it's a class that you refer to, and then you're using that variable moving forward. And that's what you're really doing. Not too difficult at all to get around it, as you can see. Well, that's great so far, but what if I have to deal with overloading? What should I do? Well, it turns out our friendly JS string, which is, remember what it is, print JS string, just to refresh your memory, it is still the good old Java lang string. Well, what if I call JS string and pass to it value of, and I'm going to say 5, and beautifully, as you can see here, it was able to print the value of 5 very nicely. But most of us know this, or you can look at the string class and you know that there is not one value of. I don't know how many there are right now, maybe 6 or 7 versions of it. One that takes a double, one that takes a string, one that takes an int, one that takes a long, one that takes a boolean, and I'm sure there's a few more out there that it works with, like a character sequence and array of characters and stuff like that. So the question is, I am here in JavaScript. Well, most of us know this already, right? Does JavaScript have overloading? Not really, right? JavaScript doesn't have overloading. I was actually teaching a session on JavaScript, and right in the middle of the talk, one guy raised his hand and said, but what about overloading? And I said, well, JavaScript doesn't have overloading. And he paused for a minute and said, damn, now I know why my code doesn't work, right? So sometimes this happens, right? We kind of realize eventually that the language doesn't have this. So you keep removing the old code every time you overload it. Again, JavaScript has that funny way of letting you know that there's no overloading, right? So you kind of eventually like, oh, that's always a wonderful, memorable moment, right? So print JString value of hello. And notice in this case, it did not blink a minute. So what really happened? Well, the Nashhorn engine is smart enough to know that while JavaScript doesn't have overloading, Java does. So it takes your input and looks for a type match, and whatever matches the type appropriately, it calls it for you very nicely. However, I want to show you a little bit of a difference you can make here. So what if you say, all right, this is cool so far, but I really want to pass a 5, but I want to call the value of that takes a double. And you never ask people why you want to do it, because they always come with crazy reasons why they want to do it, right? So you say, okay, fine, I'll show you how, and we will see how we can make that work. So here's what we're going to do. Now, one of the features that I'm going to talk about is about JavaScript itself. So if you go back to JavaScript, let's say we have a class called car, which is a function we have here, and let's say year, for example. And then within this, I'm going to say this dot year equals year. So we created a car.prototype, prototype dot drive equals function. And I'm going to say distance, and I'm going to only say here print drive called. Let's just start with this for a second, right? So I'm going to say var car1 equals new car 2014. So we have created a car object. Now I can say car1.drive, and I can specify the distance to drive, and you can see that drive was actually called. But there are times when your life is not that simple. You probably have a variable called a params, and this variable value is drive at the moment. Now remember, this params is a variable, but that variable may actually come as an input. It may come as an input in a web application. It may come as an input in other kinds of application. Whatever it is, it could be a command line argument you provide. Who cares how it comes, but it's got a parameter name called params. But I want to call the method whose name is not params, but whose value is, name is the value of the params. In other words, I don't want to say car1.params, obviously. I want to call the value, the name, which is the value of that variable, right? So one thing you can do in JavaScript is you can do this. You can send the params here as like an array, and you can invoke methods using it. This is one of the features I really like about in JavaScript. It is quite flexible in that you treat it like a hash map, and throw a key at it, and it faithfully gets a value for you, and then you are just evaluating that value with the parentheses and saying go execute that method for you, right? So it's purely like a JSON object or JavaScript object that can do that for you. So given that, what we can do here is I can simply say print line, but rather than calling this, I'm going to simply say value of, but I want to call the one with an int over here. So square bracket, so close that call, and then I'm going to specify a 5 as the value that I want to invoke. Now you can see we did what was simple before with a little bit more code here. But the benefit this gives you is you can now turn around and call the same function with a double, and you can see in this case we ended up calling 2 different functions. In the first case, we call the version that takes an int with a 5. In the second case, we call the version which takes a double, and of course 5 being an int was treated as a double. In this case, it printed a 5.0, as you can see. So that gives you an example of how we can certainly do that operation. So we saw the automatic resolution of the type. We also saw how to explicitly resolve the type. We can also get the type object itself using Java type and get that particular type information. And once we do, we can start implementing interfaces, for example. So how do you implement interfaces? For instance, what I can do here is I can say runnable with a capital R, because we are dealing with the class equals, and java.type, and we could say java.lang.runnable. So we are getting the runnable object on our hand that we want to use in this particular case, right? So we are getting the runnable object on our hand. Once I get the runnable, what do? I can say java.extends, and I can specify runnable. And then how many methods does runnable have? It simply has 1 method, but that doesn't matter. Whatever methods we have, in this case, I'm going to say run, and this is going to be a function. And within this function, I'm going to do one more thing. Var thread equals, again, I'm going to say java.type, and I'm going to define this as java.lang.thread. And now that I have object thread on my class thread on my hand, let's go ahead and play with this a little bit. So I'm going to print here hello from, and I'm going to specify thread dot current thread. So I'm going to put the current thread information in here, call that. So in this particular case, we implemented the interface, and I'm going to say runnable equals, and I just put that into runnable. So now I'm going to say runnable.run, because we know that the run is the method on runnable, and I want to go ahead and call that particular method from here. Well, let's resolve the error that it tells us. It's giving an error on line number 4. I am using the extends. I'm going to specify the runnable over here that I want to implement, and then I'm going to specify what I'm interested in implementing. This could be a JSON object. Let me make sure that I ended this properly right here. That ends over there. This guy ends over here, and then this is ending right here. So let me see what the error actually is telling me in this particular case. So cannot call, what cannot call? Undefined. So he's not happy with something I'm calling here. So let's see what that is going to be. So I'm calling the extend method right here, and I'm asking it to be extending it. Line number 9, now it's complaining. That's a little farther ahead. Let's see what the error is on line number 9. And it still says type error Java class. Let's fix that. So I'm interested in calling the run method on the object. So let's actually print the runnable and see what it gives us. So in this case, I'm going to say print runnable and see what he has. And that's a Java class. Let's actually print it with more information. So that's a adapter, runnable adapter. He has created the runnable for us on our hand. And all I'm trying to do is runnable dot run method. I'm not sure why he was unhappy with it, with the type error. So I got to look into that and see why it's complaining. So I'm calling the run method. Let's actually do without this and see if that actually goes through. Maybe I'm doing something wrong in there. What was that? Oh, a new instance. Yeah, that would be nice. So yeah, see, I totally forgot about it, right? So runnable impl. Hey, that implementation. You are absolutely right. See, that's why I like pair programming, right? So runnable implementation is the new runnable, var runnable. So there you go. So now that I have a runnable, I want to call the method. Yeah, that would be nice to create the instance. Poor thing was trying to tell me that. Thanks for your help. We can see that we called it. We could do one more thing here. We could say new thread, and then we could pass our runnable to it. How about that? And then dot start, and we could call it from yet another thread as well and see what result it produces this time. Well, okay, we called that, but we probably have to just give it a little time to finish up. So thread dot sleep and give it a little time to see what it's doing. So in this particular case, I'm calling it from 2 different threads, as you can see, and you can see that one is from the main thread, another is from the thread 1. But let me show you one small detail before we wrap this up. If I go back and remove all of these guys, get rid of the runnable as well, notice that in this case, I want to call a runnable. So I'm going to show you 2 different things. I could say var over here, and I could say, for example, run equals function, and then let's simply say here print hello from, and let's say thread dot current thread. So I'm going to go ahead and call this with this function called run. It is just a JavaScript function I'm sending to it and asking it to run, as you can see. So you could have done that as well. Or if you really want to, you could say function, and it doesn't take any parameters, and then I'm going to say print, and I'm going to say hello right here. And in this particular case, we simply used a little syntax sugar that Nashhorn offers, which is a Lambda expression within JavaScript. So you don't have to go through the ceremony of creating the function. You simply say function, and if the function were to take parameters, you can simply pass the parameters by putting the parameter names in there, and then close this parentheses and just write the code, the body of the code. And of course, we saw implementing the interface as well using the JSON notation. So if you're interested in downloading the code examples, I will have these posted later today. So if you try it tomorrow, they will be available at the downloads link. I hope you found that useful. Thank you.